Hello guys, my name is Desmond and I welcome you to my lesson for today where we'll be looking at your mathematics. So ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say, it's massively, massively, massive. Hey, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, please, 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 honorable members, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So, just at last confirmation from one of you guys. Is it clear for everyone? Can you guys clearly hear me when I speak?
Yes.
Okay, 100%. So I just made an indication that it's still load shedding on my side, but when the power is restored, I'll just need a few seconds to try and switch on the lights. So just in case if I start breaking or it becomes blurry, just let me know immediately so that I can do something. So remember guys, all that we've been doing, it was actually sequences or number patterns where there is a stand number separated by that, stand number separated by that. So I want us to actually spend more of our time talking about series in today's lesson. Remember, it's grade 12 learners who are invited. There will be some parts which we might be focusing on where grade 11s might still benefit. But if you are in grade 10, you are not advised to be in this lesson as discussed yesterday. So this lesson is actually for grade 12 learners because what we'll be doing, you only find it in grade 12. So let's see. Guys, I did indicate that when we look at a series, listen very carefully. We've got what we call arithmetic and geometric series. So we've got arithmetic and geometric series. So what I'm about to explain now, it's that screenshot that I sent in the group. So if you write some notes, it's still fine. If you don't, you can still refer to that screenshot that I sent in the group. So first thing first, you remember we've dealt with 3 types of number patterns. It was arithmetic, geometric, and quadratic. So under series, we only focus on 2, being arithmetic and geometric. So listen very carefully. When we add, bantu bakithi, when we add terms, so these are the terms. So when we add those terms of a sequence together, we form a series. So it's more like it's a very short explanation of what a series is. So when you add terms of a sequence together, you form a series. That is why I was saying the moment you see a sign of a plus in between the terms or in between the stand numbers, you know you are dealing with series. Okay, it seems like the power has been restored. Let me do these. So again, Just in case if it becomes blurry, let me know, Bantu Bagiti. So, in short, that means since we are talking about terms being added, that's where the word the sum comes in as far as this part of the chapter is concerned. The moment you hear the word the sum, you know we are talking about a plus sign. The difference, you know, a minus sign, the product, a multiplication, and then I think it's a quotient or something where we talk about division. So that is why the formula will look like something like S for the sum. So the sum of the terms, it's actually equals to you adding term number 1 with term number 2 with term number 3 with term number 4. If there are many terms, you can still add those until whatever last term number that you might add. Maybe, let's say, for example, the sum of the terms in this pattern of 2 plus 4 plus 6 plus 8 will be equals to you adding this plus that being what? 6. 6 plus 6 being 12. 12 plus 8 being what? 20. So that means the sum of this term in that sequence, it's actually equals to 20. But remember, we've got two types of series, arithmetic and geometric. So now let's try to see how the formula for calculating the sum of an arithmetic series looks like, and also how a formula for calculating a the sum of a geometric series looks like. So that means under series, it's in most cases where you need to remember two types of formulas, and then we will further break down the formula under geometric. So that was just me trying to make you visualize what we are referring to when we talk about the sums. The sums, it just means you add the total number of people staying in stand number 1, total number of people staying in stand number 2, stand number 3, stand number. So it's more like we want to know the total number of our community. Previously, what we have been doing is just to know what is the total number of people staying in stand number 1? What is the total number of people staying in stand number 2, stand number 3, stand number 4? So we just knew that in stand number 1, it's actually 2 people staying in there. So under series, we are now adding the total number of people in that community. So I'm just going to quickly remove all of this. I'm telling you guys, what I'm explaining now, it might be understandable but not make perfect sense. But when we start answering the questions, that's when you'll be having a better understanding of what we are talking about. So now, maybe let's talk about arithmetic series. I can promise you now, Bantu Bagiti, there's nothing difficult about arithmetic series. You just need to know the formula and you'll be given almost everything and you just calculate one unknown. This is how the formula looks like. It's Sn, remember, the sum of the number of terms, or the sum of n terms. It's equals to n over 2. Remember, you use sign if you're going to have brackets again inside. So that is used that to a. I'm pretty much sure that we do know very what a is, plus into n minus 1 close d, and then you have that bracket. So the moment you have this type, that means you're still going to have another bracket inside. So this is the formula by ambiguity. The moment you're dealing with an arithmetic series and they start talking about this, you know this is the formula that you need to use. So this, as indicated on the note, it is the sum of n terms. Obviously, n, we can still refer to that as the number. And then the whole of these being the sum, the total that can be calculated for that particular community, with n being the number. And then obviously A, we know it is the first term of the series. So we no longer talk number pattern or sequence, but we talk about a series now. And then n, we can still refer to that as the number, and then d being the difference. That's all that you need to know regarding an arithmetic series. There's nothing new there. So now I'm going to remove all of that, and I'm going to explain all that you need to be aware of regarding a geometric series. So just write that down, geometric series. So for the few who are attending my lessons for the very first time today, very warm welcome to Bagiti. So this lesson is being recorded, so just in case if there's something that you missed, you can still catch it up. I'm pretty much sure that tomorrow, Friday, Saturday, and today's lessons will be posted, and I'll share the links so that you guys will be able to catch up. So quickly, let's talk about all that you need to be aware of regarding a geometric series. You've got two formulas. The first one, it looks like this, is Sn, which is equals to a into r to the exponent n. Can you guys see, the moment you hear the word exponent, meaning at some point you might need to apply the laws of exponents, which is what we started with in the beginning of our lessons. I did those lessons in purpose to prepare you for these situations. You will notice how important it is for you to do such a revision. So we also have another formula for geometric series, which looks like this, into 1 minus, let's see, it's r to the exponent n, close over, we are having r, 1 minus r. I notice on my notes here, I'm having r to the exponent of 2. I think it's supposed to be n there. So I'll just make sure to correct those notes and repost in the library. So the last notes posted in the library, it was for this chapter of sequence and series. So just make sure that if you need to access these notes, you'll find them in the library, which means you need to be in the library. But now, what are the differences between these two formulas? Okay, it seems like on the first one we're having a into its r to the exponent n minus 1, and also the bottom is just r minus 1. So it's more like this one starts with r to the n minus 1, r minus 1. But this one, it starts with 1 minus r to the exponent n over 1 minus r. Hey, but now, how are you going to know which formula do you choose? This is where we say, if you are given a geometric series. Remember, under geometric series, we are dealing with the ratio and not the difference. The difference is under arithmetic. So that is why we are saying, if you are given a geometric series, and when you calculate the ratio, you find your ratio to be greater than 1. That means you choose this formula. But for some reason, if examiner gives you a geometric series where your ratio is less than 1, then it means you use this formula. So let's maybe try to check something. Let's say maybe 2 plus, maybe let me say 4 plus, maybe let me say, what is it? I think 8. Let's see. Let's try to calculate the ratio bantu bakiti. So that means it's going to be that divided by that, that divided by that. So what is 4 divided by 2? I think that is 2. And then what is 8 divided by 4? I think that is 2. So now here comes a question. Between the two formulas, which one are you then going to use and why?
It is the first one because r is greater than 1.
Yes. Yes. You are going to choose this formula because your r is greater than 1. So it means when you're dealing with geometric series, you will find your r be either greater than or less than 1. It's more like it can't be 1 because the moment you start having 1, you're going to have either 1 minus 1 or 1 minus 1, which gives you 0, and then the whole of that, it gives you an error. Because I think anything divided by 0, it gives you an error. So it's already a hint that when you calculate your R being your ratio, it's either it's greater than or less than 1. So if it was less than 1, that means we were going to use that formula. So remember the ratio, the word ratio, whether in physical sciences or whatever, ratio means something over something. Ratio means something divided by something. Ratio means something per something. Ratio means something is to something. That is the ratio bantu bakiti at all times. When you hear the word ratio, just remember that it refers to something over something. Very, very much important, ladies. Now, quickly, let's discuss what is what. Obviously, this is the sum of the terms. This is the first term. Obviously, n a number of terms or standard numbers are. Let's try to pretend that we are intelligent. We don't say R is ratio, but we call it common ratio. Let's call it common ratio because we know that under geometric series, the R is constant or the R is common. So let's try to respect R and refer to it as common ratio. So that's all bantu bakiti that you needed to be aware of regarding that a geometric series formula. So now I'm going to remove all of that and then quickly try and have a look at those questions. It seems like we still have some time. We might as well quickly go through those quadratic questions. So now I'm going to remove all of that, and then from there we will start having a look at those problems. So let me quickly see in here what we've got. But did you guys see the question that I sent in the group? Is it everyone who saw those questions which were sent in the group?
Yes, on my side, I received them.
I think it is everyone who got those. I'm just trying to connect here and bring those questions. But I want to quickly ask Hamisa something, and also that honorable member. Do you guys still remember that today we learned that we can have, I think, what was it? Was it DN plus C, a shortcut of determining the general formula of an arithmetic number? Let me see if Moleboge is here. I'm not sure if she is in this lesson. Moleboge.
I am here.
Okay. Hamisa, I forgot that honorable member, but I remember you seemed to be aware also. Do you know where that formula comes from? Or do you know or understand how it ended up being like that?
Yes, are you speaking about how it came to be? Yes, I do understand.
Okay, so I wanted Hamisa to also respond to that. Hamisa, do you know where that formula comes from, or you just know it as it is? Someone needs to remember to mute their mic. I think it's Hamisa. Hamisa.
It's Rose.
Rose is speaking. Rosie, are you saying something that side? Rosie, Rose Matloko. I'll need to mute a Rose from my side. Hamisa, were you trying to say something there?
I was asking if you're asking how I found the formula.
Yes. How did that formula end up being like that? Do you know, or you just as that?
I don't really know the upbringing of the formula or how it came out, but I found it in a past exam paper and I tried it and it worked, so I used it.
Okay. Makes sense. So I just want to actually make use of this scenario to explain something. Moleboge, I want to bring it to your attention. The reason why I say we've got different types of people. We have those who know something, and we have those who understand something. So what I'm actually trying or hoping to achieve in almost all of my lessons it's not really to just make you know things, but to understand exactly what maths is. That's what I'm actually trying to achieve. So, Moleboge, you just know how to apply that formula, isn't it? You know how to use it, isn't it?
Yes, I do.
But you don't know where it's coming from.
To me, because I had it, I saw it yesterday for the first time. I have an understanding of where it comes from because I saw it yesterday myself.
Yeah. Okay. So now, Hamisa, you will have a better understanding of what I'm trying to explain. So you need to get a level where you can be able, for example, to derive a formula similar to that. Let's try check where that formula might be coming from. Remember, the original formula, what is it? It's A plus into N minus that, and then you're having D there. So if you work out that, you end up having A plus that by that, that by that, and then that is Dn minus what is it? D. So you end up having this being positive Dn plus being that A, which is A minus D. So what they did, this alone, it's a constant. A constant is just a number. So maths, when we want to talk about just a number which could be 0, -1, 1, or any negative number, any positive number, call it a constant. So what they did was to say D is D, N is N, and then they say plus this. They then represent it by C as a constant. That's why you need to know what that C is, which is what I asked honorable members to say, what is what? They knew how to apply this formula of is good. You do know that when you understand maths, you are therefore able to derive where that formula comes from. So what I'm actually saying is it's not at all the times where I achieve this in all of my lessons. So what I'm saying is that this is what, for example, in class, they give you as it is. But what I'm hoping to achieve in my lessons is to actually help you understand where that comes from. That's what I mean by someone understanding maths and someone who knows maths. Those are different. And what is, if you're in grade 12 and you get something similar to that, or it could be something different from that, and it's complicated, it's in most cases where learners do not really understand that. For this to end up being like that is because in grade 10 and 11, this is what they used to do. So when you get to grade 12, it's summarized. Then when you get to grade 12, you abandon all that information, but get confused by that, not being aware that this is where it's actually coming from. So the struggle in grade 12, its solution is in the previous grades. If you can see yourself not being able to solve a grade 10 and 11 problem, it's because you probably at a stage where you know maths, but you don't understand math. So when you are in grade 12, you should be able to solve any problem in grade 10 and 11. That's how you gauge yourself in terms of whether you either know or understand maths. So my Wi-Fi is now connected, and I think we can start having a look at those questions posted in the group. But before I do that, Hamisa, were you able to understand what I was trying to explain there, or it didn't make any sense? Moleboge, are you there to respond to that same question?
Yes, I understand right now. I understand how they got to that equation.
Okay, 100%. So now, quickly, let's try to work out that question number 2. I think it's worth it for us to quickly work it out, because with you understanding what is it? Quadratic sequences, you stand a very good chance of being able to score some marks under this question. So let's see. That question 2, I hope everyone is able to. They're saying the first 4 terms of a quadratic pattern are, those are the first 4 terms. We know the type, then now we need to do the difference after knowing the type. So let's see. What is 29 minus that? 29 minus 15 is 14. What is that? 41 minus 29 is 12. What is that? 51 minus 41, that is 10. So it gets easier to get the difference in this. You know is 2 is 2. Then now you show you are having, what is it? A quadratic pattern. So the first question says write down the value of the 5th term. Let's see, we have 1, 2, 3, 4. So this is the one that they want. Obviously, for you to know what this value is, you start from the bottom where you say plus 2. It gives you a number which is 12. Then you are going to say 51 plus 12. What is that? Is 63. Can someone just cause this is 6? No, yeah, this is 6. 1 plus that is 3. So that's how you answer that first question.
The difference is actually negative 2.
Oh, yes. Yes. Is it everyone who agrees that honorable member there?
Yes.
Yes, I agree. It's negative 2.
Which is a very good indication that if you try make yourself a ndondo, you will end up getting a hammer. In this instance is where you just see 14 and 12 and you think of 2. You just see 12 and 10, you think of 2. Rest, it's actually negative 2. So this negative, it actually affects that number. So that means it is 10 plus negative 2, which is what? It's going to be 8. So now it also affects that, which means it's 51. What is it? Plus 8. I think it's 59. Is it not 59? Yes. I think it has to be 59. So now let's see. The second question is determine an expression for the nth term of pattern in that form of n is equals to squared plus bn plus c. So you already know that one that in that form. Remember, guys, this is your last opportunity to ask questions related to that, because starting from tomorrow, I'll be doing functions. It's going to be a lesson for grade 10s. But if you know that you don't understand maths, but you just know maths, please attend. Whether in grade 12 or 11, just attend that grade 10 lesson, because That is the foundation, and builds up from there. So let's see. That means you just need to give us the A, the B, and the C value. That's all. So let's quickly try to work it out. We know that we are having, what is it, 2A, which is equal to that, of which it's -2. And we have 3A plus B, which is equal to 14. We also have A plus B plus C, which is equal to 15. You need to know this by heart. It seems like when you're given a quadratic pattern, it's very, very much easier, guys. Let's see. A is equal to -1. So here we have 3 in -1 plus B equals 14. Then B is equals to that -3 to the other side, it becomes +17. So that means we have -1 plus 17 plus C equals 15. Then what is negative that? That is 17 minus, which is 16, plus C equals to 15. C is equals to, so you take that to the other side, is 15 minus 16, which is -1. So in the end, you just substitute. What is your A value? It's -1. You don't need to write 1. You can just write that. And then what is your B value? It's a +17, and you see it's -1. So you've given that in that format. I'm not sure if there's someone who's left behind on that question, or are we all on the same page on that one?
We good, sir.
Matule, are we together there?
We are together.
Okay. Rose, I had your mic muted because there was a background noise. So I managed to allow you to speak in case if you need to ask a question. Okay, so now that we're together, let's quickly have a look at that 2.1.3, which is allocated 2 marks. They say determine T27. You get a mark for correct substitution, and again for final answer. So that means where you see N, you're just going to substitute 27. As you can see, this is the position for N where they substituted that. So that means what is the answer there? What will be that answer there?
-271.
-271. Last one to confirm, is that correct, that answer there?
Yes, sir.
Okay, so Moleboge, I think this chapter will always remind me Moleboge. For some reason, I don't even know why. I think maybe you are the one who started participating when I started with this chapter. But I just know for some reason, I feel like if I can explain to such an extent that you understand, I'm just having a feeling that everyone is going to understand. And I think it's because you did these things a very long time ago. So you're now refreshing your mind. So that means if I can make you understand, almost everyone will understand. But this is what I want to explain, Moleboge. Can you see this formula that we have just used to calculate T27? It tells us the total number of people staying in the number 27 on the other side of the road. So when it comes to series, the series, it adds everything. It's not only the total for a specific number, it adds everything. So it's more like we are calculating the total number of people in that community. That is why I'm using the word community. I'm not sure if you get what I'm trying to say there.
I'm with you.
Yes. So we are now upgrading our level of understanding. So that is why I would say it was worth it for everyone to start at the starting point. Because imagine if, for those who like asking, the lesson is for which grade. If, for example, I just started at this level for grade 12s, that means we wouldn't have discovered that there could be something that can be referred to as a stand number and total number of people staying in that particular stand number. I would be talking about series, and you wouldn't have a background of what we would be referring to. So now let's quickly move on to 2.2. So I was trying to adjust my thing there. Let me quickly do this adjustment. Bring back I'll bring back the screen, but I just need to quickly adjust this. So on your side, what you should be doing is just to have a look at the question that we are about to. So I'm about to bring back camera now. I'll need you guys to just confirm if you are able to see. Can you guys see? Guys, can you?
It's a bit
Or is it
blurry on
heavy?
my side. On my side, it's a bit blurry.
Okay, I'm active. Then I'll need to quickly leave and back. Maybe to this. How about now?
It's clear, sir.
Okay, so let's quickly have a look at 2.2. Let's see. They say given a geometric sequence. Given geometric sequence, we are having 6, we're having negative that, we are having that, and then say you still have small. Remember, for arithmetic and geometric, only need 1, 2, 3 terms, but for quadratic, you need 4, so that you have 2 differences which you can compare common or not. But if they give you only 3 and this is a quadratic, so that means when you do that minus that minus that, and you say that minus that, whatever number that you get, it is common. So you shouldn't worry if you're getting 3 times. So let's do a geometric sequence. You need to remember that you either have a, what is it, a series or a sequence. The moment you see those, you know you are dealing with a sequence. So 2.2.1 say determine the value of R being the common ratio, which is 1 mark. Who can give an answer for that one?
So what's the question again?
So the question is, what is the common ratio? Quickly, it says determine the value of R, the common ratio.
It's a 1,2.
That true, honorable members?
Divided by
Yes,
2.
sir.
Yeah, so this is how you get it. So it is not divided by that, which is negative 80 divided by 36. If you're on a calculator and it gives you a simplified answer, so that means it's negative 1/2. To confirm it, you need to say that divided by that, check what you get. I think it does give you negative 1/2. That means in answering the question, you're just going to say R it's equals to, you can either say 9 divided by negative 18 or that divided by that, and you end up having negative 1 over 2. So that is how you calculate R being the ratio. And indeed, you can see it is not just the ratio part, CR being common ratio. So quickly, let's move on to the next question, which says calculate N if the N is to that. Yes, calculate N if Tn is equals to 9 over 4,096. Umi, isn't this question a bit scary? It's given, it's located on 3 marks. I know that thing from 1 to 3 is not really complicated. But this one, any idea of what's going on there, debate? Any idea? Remember, if you have no idea, please mention so and say no idea so that I'm aware you did get my message. If you quiet, I'll think maybe the message is still on the way.
You substitute the given number in the formula of AR to the power of n minus 1, I think, to find n, because Tn will be like Tn, then you write that specific number, then it will be equals to A, which is 36, R, which is negative half, then we'll be looking for to the power of n minus 1, something like that.
Kancane kancane uyavela. Kancane kancane uyavela. Lombo. Now I understand when they say Lombo. Kancane kancane uyavela. This is what Honorable Ba is saying, Bantu Bakiti. Can confirm this one. You do know very well that the moment you see N, the general form. So that means T of a geometric sequence. How does it look like? Is A R to the exponent n minus 1, what we know. So that means what is A? That is 36 multiplied by, remember, as R put it inside the brackets, for a geometric sequence. What is our R? Is it not 1 over 2? Close. Obviously, we have that and that. So this is our general formula for Tn. That's what we know. Then what Hassan is saying is that we take this, just there and equate it to that. Then we solve for n. So it means the whole of that is equals to that. Then maybe I can just remove that, so that you guys are able to see that I'm actually having the whole of that, which is equated to the whole of that. This way, I used to ignore the questions of which grade is this. It pains me, Bantu Bakiti, it pains me a lot when one asks which it is. But I understand they are not aware. Now, you need to trust the process, Bantu Bakiti. Just trust whatever we do. I was explaining to an honorable member to say, we are not really doing what you guys are doing at school. We do what works. What I'm doing is well tested. It did work, and I'm pretty much sure that it will all work. for you guys. It doesn't mean because you are in grade 10, you can study the stuff in grade 11 and 12. It's more like you meeting your capacity. The brain is such a powerful tool. It's a very powerful tool. You might find that some other countries, the standard of grade 12 is standard, the standard is grade 10. Let's never underestimate the capacity of our brain. Let's see now how we're going to work out this thing. That's why you need laws of exponents. Say, let's make rid of that. Why? Because we want to detach everything close to the inches. So that means I'm saying let's divide both sides by 36. Why? So that cancel that and we just remain with a negative half to the exponent of n minus 1, which what is that? What is that? What is that? I need to
81, 81 over 1024.
81 over 102.
424 1024.
Is it everyone who's getting that answer? Mm-hmm. Guys. Why is it like you guys are watching family? It seems like you guys are gone. Bantu Bagit, what is that when you punch it on your calculator? What is that? Umi, how is doing my family there? Seems like you guys are watching. Let me see. Danny, are you there? Cien. Hey, are you guys there? Did you punch that? Guys, hi. Hamisa, what is this? Minentle, did
I
you
can't
guys
start
punch that?
because I
Yes,
lost my calculator. I don't know where I put it. So
I
sir.
couldn't hear what Hamisa is saying. Is Hamisa saying, so are you struggling to punch this, guys? Is it tricky to punch this on a calculator?
So I'm
no,
getting
it's just
decent
that
answers.
I don't have a calculator now because I lost it. I don't know where I put it.
Oh, Hamisa doesn't. Okay, those who have their calculator, what is this? What are you getting, Omi? I heard you saying something there.
I got 1 divided by 16384.
Yes, that's also what I'm getting. A honorable member who got this answer, try to punch it again and check if you still get that or you're getting what Muzozo will get when she punches that. So I'm also getting 1 over 16384. This is what I'm also getting. So Now, can you see? We somehow need to make the bases the same. So that we'll say when the bases are the same, the exponents are also the same. So how can we possibly do that? How about
Sorry, say
Yebo?
I'm still getting 8 1 over 1024.
81 over 1024. Okay, how are you punching that? Remember, you start with the fraction button and then you punch it again. Then you say 9 at the bottom is 4096. At the bottom is 36. Then you say it's equals to. That's how you punch it.
Oh, say thanks.
Yeah, so avoid using this division sign. It's a bit dangerous to use that. So I think let me remove something so that I can continue with that. Maybe let me remove all of that. We'll just rewrite it if we need. So we are having a negative 1 over 2 n minus 1, which is equals to 1 over 16,384. So this is what I would do, guys. Because I want the basis to be the same, I'm going to force this one also to be the same. So we're having that n minus 1, which is equals to. So I used to just do this as it is and test a lot of exponents until I get one that gives me exactly that. Then I know I'm going to say the bases are the same, they fall away, then I equate the exponents. So that means I would say into negative 1 over 2 close, then I start maybe with 3. Can you see 3? It doesn't give you that. I'm going to change that 3 and punch. Maybe let's jump to 5. 5 it doesn't. Let's delete. Maybe let's jump to what? 5. Maybe let's go to 8. 8 it doesn't give me that. Let me jump to 12 maybe. 12 it's 1 over what is it, 4, it's a little small. Let me maybe jump to 16 and see what I'm getting. No, I did a big number there. 16 is 65. 16 is bigger than 1 over that. Let me go back. Maybe let's try 15. 15 is that. Let's try 14. I think we skipped 14. Yes, can you see? It works when you have 14 there. I'm not sure if you guys agree with me. So if you are having negative 1 over 2 to the exponent 14, it gives you exactly that. So that means I can say now the bases are the same, then they fall away and I can equate the exponents, which means n minus 1 is equals to 14, and then n will be equals to 15 because you take that to the other side. I'm not sure, guys, if you are happy with that calculation. Does it make sense to everyone? Hmm. Silence in court.
Everything is good on my side. You can continue.
Okay, so now let's quickly move on to the next question. So I'm just going to remove all of that. So what's the next question say? Let's see there. It says calculate this thing, the sleeping 8. Used to call it the sleeping 8. They say this thing, calculate sum to infinity. This thing formula, guys, let me quickly go to the formula sheet. It has a formula and case, that is A over 1 minus R. And that if your is between what is it? -1 and 1. So you use this formula if your R is between -1 and 1. A value which is between -1 and 1, that's if we have what? I think 0, it's in between. Even numbers like -0, it's in between. Even 0,5 is in between. But anything like -2 doesn't apply. Anything like 2 or 1,1 in that direction, it doesn't apply. Also, even if it's -1, because you can see they're not saying equals to, they're saying less. So anything between those. So the question is, our R that we calculated, was it between -1?
Yes.
Was it between -1 and 1? Yes. So that is why we will easily be able to calculate and say, no, our A value there. What was our A value there? Was it 36? Someone confirm.
It was 36.
So, yes. So you need to be careful to substitute your R inside the brackets because it's a negative number. Otherwise, someone is going to say 1 minus that, and you get the. So what is the answer there? The sum to infinity. What is the answer there?
$24.
Is it everyone who's getting 4?
Yeah, it's 24.
So
Okay, then 2 marks. It is as easy as that. No need to stress much when it comes to that. So let's see, where are we? 2.2.4. So there is a tricky question. You can see it's allocated 4 marks. They're saying calculate the value of T1 plus T3 plus T4. No, T1, T3, not T4, but T5 plus T7 plus whatever the T is, and the last one is T499, and that divide it by T2 plus T4 plus T6 plus T8 plus whatever terms in between, where the last one is term number 500. Yes. Let me quickly try to write that sequence again. Remember, we had 36, and then we had -18, and then we had 9, then had whatever there. So with this type of questions, guys, examiner is trying to be smart, is trying to play some tricks, but there's something that you need to always remember. Very, very much important, ladies and gentlemen. Here at the top, it's actually the sum of what is it? I think is the sum of let's see, odd numbers. Yes, it's the sum of odd numbers of that sequence, and then here you're having the sum of even numbers. So I'll give you guys an example. Let's say we are having 2. Let me not use the plus, just that it makes sense. We're having 2, 4, 6, 8, 10, 12. 1, 2, 3, 4, 5, 6. This is what they are saying, This is obviously term number 1, this is term number 2, term number 3, term number 4, term number 5, term number 6. So what they did there, on this same number pattern, they just focused on the even numbers. Remember, the even numbers are numbers which are like 2, 4, 6, 8, whatever. But maybe let me do this. If you have 1, 2, 3, 4, 5, 6, 7, 8, the odd numbers are the numbers that you can not divisible by 2. You can't divide them by 2. For example, that one, when you skip a number, that one you skip another number, that one you skip another number, that one. These are what we call the odd numbers. Then this one of 2, 4, 6, 8 are what we call the even numbers. So if you look at that, it's more like they want you to get the sum of the odd numbers, and then you divide them by the sum of the even numbers. So if I had to answer that question using this, or not even this part, now we are talking about that. Let's remove all of that, because here I was just explaining what an odd is, what an even is. Still great, still 10 stuff. If you can remember from grade 10 what an even is, what you're in trouble. So that means they took they want you to take the odd numbers, which is going to be term number 3, of which in this case is 4. You must plus it with not this term, because this is even. They want you to take the odd numbers, which is number 1 is a number, that is a number, and that is an odd number. What is this plus that plus that? So that is 2 plus can you see I'm already substituting. Term number 1 is 2. Term number 3 is what is term number 5. What is it? Is 10. I want you to divide it with term number what? 2, which is that one, being 4. You plus it with next even number, which is 8. You plus it with next even number, which is 12. That's what they want you to do. This is what? This is 8, as that is 18. So smaller you have 18 divided. This is 10, and then 22. So that is 22. Then if you further work this thing out, it gives you a certain number. Let's see what that number is. 18 divided by 22 is equals to 9 out of 11. So what they want you to do, Mzozos, it's exactly what I did, but when you use that sequence, I'm not sure if you guys have an idea of what is going on there based on what I've explained. Does it make sense, or did I lose you completely there?
Matima, say it's 18 over 24, not 22.
Oh, yes. So that means we're together. Let's see. But do you get the concept? I just wanted to confirm that. But do you get the concept there? So it's 3 over 4. It's 3 over 4. So I just wanted you guys to have an understanding that what you need to do on that question, it's exactly what I've just done there. The only difference is that that sequence is different from this one. So maybe let's answer the question and see if it makes sense. So obviously you can't extend this by saying 36, that, then you multiply until you have 500 terms. Too much. That's why you use a shortcut being the formula. But you need to be careful there. You need to be aware that that means the total number of terms is actually 500. So that means you have 250 even numbers. You also have 250 odd number. That is the first thing that you need to be aware of. That is why for that question that I only had how many? I think it was 8, and out of that 8, 4 went above, over 4 went below. That is what I'm saying. It's actually half of the total. I had 8 and half of the total was 4. So that is why I added 4 and then I divided by another 4 below. So the difference between these two is that mine, it was just up to 8. But for this one, it's up to 500. So if you don't want to use the general formula, it means you need to add, you need to say this times negative 1 over 2, it gives you that times negative 1 over 2 times 1 over 2, and then you do 500 times. Then from 500, you're going to say this, you skip that, plus that, you skip, plus that, you skip, plus that, you skip, plus you skip. You're going to 850 times where you're in the even, the odd number. You do the same for the even. You add this, skip that, add that. And then you are also going to add 200 times. Then the answer that you got when you added those, you divide by the answer that you got when you divide, which is a very long process to do. But now, that is where that formula comes in, the shortcut, where you say, let's see, the sum of that formula. Which formula are we then going to use between those two formulas? Remember, we have one which is r to the exponent minus, no, not that, to the exponent that minus 1 over r minus 1. We also have another one which is Sn is equals to a into 1 minus r to the n, that 1 minus r to the as that. Yes. So the question is, between these two formulas, which one are we going to use? And why?
The
Let's
second
say
one.
this is A, this is B, or first and second. Why the second one?
Because our answer was negative 1 over 2.
Because what did you see there? What did you see there, Umi?
Because our alt was negative 1 over 2.
Which is?
Which means is B.
Okay. Remember, this is where you need to remember that we have one where we say r is less than 1, and then we have another one which says if r greater than 1. So our r, is it greater or less than 1? Remember, the r, yes, is less than 1 because the r that we calculated is that divided by that, which was negative 1 over 2. So that means we use the formula that says you only use it if your r is less than 1. So which formula is it? If you remember when I started with this lesson, I have those two formulas. So which one are we going to use? Is it this one or that one?
The second one.
The second one.
The second one. Okay. I did ask that question on purpose, just so that based on what you've responded, I'm going to further say something which will then make you to have another perspective. So remember, guys, we now need to separate that into a sequence that has only even numbers and another one that has the order. numbers. That's where it gets tricky with that question. That's where it gets tricky with that question. So remember, guys, that means when we're focusing on the odd numbers or the even numbers, obviously, if we consider the first one, then we're going to skip that one and then we move on to that one. So it's more like we're having 36 and again we are having 9. This is for the odd numbers. So we can calculate the sum for the odd numbers, and then after going to also calculate the sum for the even numbers. So it's more like what we're trying to do is to actually to calculate the sum of the odd over the sum of the even. So now that means we are going to calculate the new R, which is the R for the odd numbers. So what is that R for the odd numbers? So it's going to be this divided by that, which is what? Yeah, this question I thought it was easy,
Over 4, sir.
but it's not. It's
1
1 over
over
4.
4.
1 over 4.
Yes, it's 1 over 4. So that's why you ask yourself a question. This 1 over 4, is it greater than 1 or is it less than 1? Obviously, it's less than 1. So
Less
if
than
it's less
1.
than 1, that means which formula are we going to use? Is it the first or the second one?
First one, sir.
The first one. Okay. So now let me then remove all of that and substitute. So that means the sum, remember, we're starting with the odd. So that means it's going to be A. What is A for the odd? Is 36. A for the odd is 36. Yes, it's 36. Into what is our R for the odd is that? What is N? N, that's where you put 250. Because the question is, how many odd numbers are there in that sequence that ends with 500? Is half. Just like I did with my 8 terms. I know within a sequence of 8 terms, half is even terms, half is odd terms. Then you say, what is it, -1, you close all of that divided by 1 over 4 minus 1. That's what you guys are saying. Then what is an answer for? Guys, are you calculating there? Okay, let me calculate. So 36 into 1 over 4 close to the exponent 250 minus 1. You at the bottom you have 1 over 4. You close minus 1. I'm having 48. I'm not sure if you guys are getting 48. Guys, At this stage, you should be able to punch that on a calculator. If you are not able to punch that, then it's a very serious problem, because when it comes to this chapter, you will need to be able to punch that on a calculator. So, are you guys getting 48? Or maybe you're not getting that answer. If you're not getting that answer, then I'll need to explain how to punch it. Just let me know. It seems like everyone ran away. Tandy, usasekhona lapho?
Yebo sir, sasekhona.
Are you punching? Are you winning with punching that?
I'm still punching, sir.
Hey, Umi, are you also punching that side?
No, I cannot see, sir. Can you please read it again? It's 36.
So it's 36 into. So remember, you just substitute the info that we have into that equation that you guys chose. Is 36 into, what is our r? We know it's 1 over 4. To the exponent, our n for the order is of that total, which is what? 250 minus 1, you close. At the bottom you have r being 1 over 4 minus 1. So it's more like on your calculator, you punch it exactly as it is. Are you still fighting that side, honorable member?
Yeah, I'm punching as well.
So what type of a calculator are you using? Is it this type of Casio that has fraction patterns? Or is it
Yes,
that sharp?
I'm using the
Casio?
exact one, the one that you are using.
Okay, so just make sure to punch it exactly as it is there. Maybe let me write it in big. I'm very much surprised that you guys are still punching there. This is 36. You are having 1 over 4, 250 minus 1. You close over 1 over 4, close minus 1. Hey, guys, I'm telling you, you won't have this time that you are having in exam. This one you need to quickly sort it out. I'm well aware that even though you might punch all of that and you get 48, I'm well aware that it doesn't mean you fully understand what we have done there. But believe me when I say, I used to get this type of questions where it's difficult, but I can follow what they were doing in the memo. So for you to fully understand this, you need to do it multiple times. Don't do something new. Do exactly this same thing multiple times. It will get to a point where you are now starting to have some light. And when you do other questions, you'll also have some light. So don't worry if you punch, you get 48, but you still don't understand what's going on. It happens, and it happens to everyone. So don't say because you've done it once, then you know it. You don't know it. You need to practice it and practice.
No, I got the 48 one. Because I used to leave these big brackets. I used to leave this big bracket, so I could not get the 48. But now after putting the brackets, I'm getting the 48.
Yes, very. So you can see the impact of a bracket. It can cost you some marks. So now you also do the same for what is it? For the odd. No, we just did for the odd. Now we do for the even. So let's see, this was 48, the odd. So now let's do for the even numbers. So for the even numbers, we know we are having negative 18. We will need to jump this one and use that one. So what will this number be? What is term number 4? It's more like I'm saying, what is term number 4? Do you guys know what term number 4 is or how to calculate it? So can you guys see now?
Yes, sir.
You're going to say 9 multiplied by the ratio. What is our ratio? Our ratio, I think it was negative 1 over 2.
Yes, sir.
Okay. So does it mean this term here, is it negative 9 over 2?
Yes.
Okay. If that is the case, then what is the ratio for the even numbers? But do you guys understand what I mean or why we needed to find this? It's because we wanted to calculate, because we've done a calculation for what? For the odd numbers. Odd number, it starts from 1, and then you skip T2, then you skip to number 3. But when it comes to the even numbers, you start from 2, then you jump, and then you go to this one. That's what we needed to know. What is this term here? So now the question is, what is now R for the even numbers? What is R for the even numbers?
1 over 4.
Yes, it's still 1 over 4. Then we do the same. 1 over 4, is it less than 1 or is greater than 1? So can you see we're still using the same formula? So now you substitute. Let's try to see how it looks like. So that means is the sum of, you can either say even numbers or 250 numbers, because we know the even numbers are also 250, just like the odd number. So it's more like it's a half of total. How do you know the total? This is where that total is given. They're saying the sum of those. Why 499? Because 499 is a continuation of the odd numbers. If you start from 1, you skip, you jump to 3, you jump to 5, you jump to 7, you jump to whatever, you jump. As you continue jumping, you will get to the last jump being 499. And then when it comes to the even numbers, you start from 2, you jump 3, you go to 4, you jump 5, you go to 6, you jump 7, you go to 8, you jump up until the last even number, of which the
Sir,
last even 500. Yes.
so how do we get the ratio of the even number again?
The ratio. Okay, so you punch this exactly as it is, which is negative 9 over, don't use this divided by, use the fraction, say negative 9 over 2. Then that's when you can say this divided by negative 18. That's when you get that. And then now let's see, what is A? Because obviously we're still using that formula. What is A of the even numbers? Is it not negative 18? What is R? We are still having 1 over 4. What is N? 250 minus 1. Then you close. Over. What is R? We still have 1 over 4 minus 1. Then what is the answer there? Let me quickly punch so
Negative
that you have
24.
a feel of how fast you should be able to cut. So you're going to say fraction button, negative 18, you open again, 1 over 4, you close to the exponent 250 minus 1, you close, you go to the bottom, open, 1 over 4, you close, and then you say minus 1, so get negative 24. So that's how fast you should be when punching that type of calculation. So now, Moleboge, once you've done all of that, what you need to do is to say the sum of, what did they say there? The sum of odd divided by sum of even. So what was the sum of odd? Was it not 48? What is the sum of even? Is it not negative 24? Then what is this divided by that? That goes, I think it goes 2 times. Is it not negative 2, the final answer? That's it. I think question. This is what happens, guys. This question looks like it's complicated, but it is not. It is just long. Because if a different question comes, you still approach it the same way. This question, it wasn't complicated. It was just long. If it comes again, you still do it the same way. So I think for now, let me leave it there. But quickly, let's do the last two questions. We're going to skip all that is under that quadratic. We'll only do question 2.2, which is the last two questions. I'm pretty much sure that once we have done that, you will have an idea of how tricky questions may be. So let's see. If you're able to see that question, it says a given geometric series. Geometric series. It comes in different ways. Look at this one. You're given 5 over 8 plus 5 over 16 plus 5 over 32 plus whatever, and when all of them add together, they are equal to k. You guys see the question in the group before I continue? Guys, can you see that question in the group?
Yes, we can see.
Okay, so this is what you are given. Let's have a look at the question. So that other question, 2.1, you can give it a try on your own. I'll just give you some tips in terms of how you approach it. But let's see. Given the geometric series, which is that, they're saying determine the value of k if the series has 21 terms. Very interesting. This is what they are saying, Moleboge. They are saying this community has a 21 stands. And then now, this is the first stand that has 5 over 2 people. The second stand has 5 over that. That has that over that. Then you still have some more, and all of those stands adds up to 21. And then when you add all of them, they give you that. So it's either you have the energy to know what the ratio is, and then once you know the ratio is constant, you can test by saying this times that ratio. If it gives you that, you times by ratio, it gives you that. You can times, and then you get all the 21 terms, and then you add them together. That is the manual way of doing it. Otherwise, if you don't want to do it that way, that's where the formula comes in. So now, can someone tell me what is the ratio for that? This is where it gets interesting, guys. The principle is the same, but what's tricky is how the values are given to you. Can you see? They're trying to confuse you there, giving you some fractions. What is the ratio there? You know, on my side, it's more like you guys, the time that you take, it's like you start by praying first. Tandi, are you guys working on that, or you start with a mini prayer?
No, I just wanted to hear that. So are they getting what I'm getting?
Hey, you might find that everyone is waiting, and we are all waiting. Alex, are you also waiting that side?
I'm
Is it that
calculating, Munir. I'm
situation, or
coming now.
did you start with a prayer? Hey, Matapelo.
No, I'm about to finish.
Bantu bakithi. Hey, niyamphoqa. This is what you do. 5 over 16, you go to the other side, you say divided by 5 over 8. It gives you 1 over 2. That's 8. That's why I say I feel like you guys are inviting young sisters before. Let's see. 5 over 35 divided by 5 over 16. Hey, 5 over 35 divided by 5 over 16. Hey, I think I need to pray here. I think I also need to pray. Wat gaan aan hierso bantu bakithi? Wat gaan aan? Did I copy that correctly? Yes, I've copied it correctly.
Yes,
Okay.
it's
5
also
over 16 divided by 5 over 8. I'm getting 1 over 2. Okay. Let me see the difference there. 5 over 32, not 35. Yes. 32 there. Okay. Divided by 5 over 16. Yes, it gives 1 over 2. So, can you guys see that it does happen that you know what you're supposed to get, but you're not getting it? Then you need to suspect that you might have done something wrong. So that's how you detect what could be the issue. This is you in exam and you don't get what you're supposed to get. Then suspect that you copied something in. Okay, so now you ask yourself a question. Between those two formulas, which one are you going to use? So is this game, Moleboch, of asking yourself which formula are you going to use? You just need to remember how the one looks like, which says if r is less than that, how the one looks like, which says r is greater than 1. You ask yourself a question, is half greater or less than 1? It's less than
It's
1.
less than
Okay,
1.
so which formula are you going to use?
I'm going to use the A bracket 1 minus R over N bracket. That's the one that I'm going to use.
This one. Is this the one that we're going to use, honorable members?
Yes.
yes, sir.
Okay, let's use that and see what are we getting. So can you see, this is where you need to be good in punching on your calculator, because otherwise kuzazoshupha 1 over 2. You need to be able to punch it exactly as it is. What is our n? Our n is the total number of stands. They said is 21, and then over 1 minus 1 over 2. That is why it's better to always have those inside the brackets. So let's see, what are we getting there? Molebogeng, why o ka re ke kwa motho a re ntate e shwa mo dimong ka moo?
Ke thola 1.20, kana ka re 1.25. I don't know if I've punched it well.
Okay, another honorable member, what are you getting there? So that means you round it off to 2 decimal places, ne?
Yes, sir, it's 1.25.
Yes, this is exactly what you need to do for that 3 marks. So remember, guys, anything allocated 1 to 3, it is as simple as you think. It's just a matter of you being able to identify the correct formula, you substitute, and then you punch on your calculator. That's it. So now let's quickly move on to that last question. Can you guys see they're saying determine the largest value of n for which Tn is greater than that. And this question is allocated 4 marks. So yesterday, when I was talking about me playing the chess game and the chess game contributing towards my thinking abilities, it is in these instances where, for example, you don't even understand what that question is. But based on what you are given there, you can derive something to work out something. I'm sure someone can also guess how to work out that. Anyone who can guess, Bantu Bagit. No idea. Minentle, are you still thinking that side or you've got no idea?
No idea, sir.
Mwanama Mage, no idea. I see we have Sma Kamasinga Kumete. Sma Kamasinga Kumete. No idea. We also have Nombuzo Makaula. Nombuzo Makaula, do you have an idea of what can there? I think it's a no idea for almost everyone. But okay, let me remove maybe that portion there. But I'm going to assume that myself also I don't understand that question at all. But what I know is that they are saying calculate n whereby Tn is greater than 5 over 8192. That's all that I need. This is where Moleboge, previously I said you would agree with me that Tn it refers to the general formula of a geometric sequence, since in this case we're dealing with a geometric sequence. So we do know the formula for Tn. Is it not Tn is equals to a r to the exponent n minus 1? I'm not sure if you guys agree with me on that one. So that is why I'm saying, let me remove all of that and say, based on them saying determine the value of n whereby Tn is greater than that. So that means I need to just find that Tn and then just say greater than that. And then I'm having an inequality.
Sir,
Yebo.
I'm not sure if it's only me. I can't see the screen.
Is it only her who's able to, who's not able to see the screen?
Yes, ustakile sir.
It's blurry.
Oh, okay. Okay. Maybe let me leave and then I'll join again. Let me. How about now? Clear.
It's clear now, sir.
Okay. So what I was saying, maybe let me remove all of this. I was saying, based on that statement which says determine the largest value of n for which Tn is greater than that. I'm just saying, even though I might not be able to easily interpret the statement or fully understand what they say, but they've actually given me a formula I can use. So remember, Tn, it only works if you're dealing with a sequence and not a series. Otherwise, if it was a series, they were maybe going to say if Sn is greater than 5 over 8,192, then you know you need to use the formula for calculating the sum and then say greater than that. But in this case, they say Tn. And when it comes to n, we know since we're dealing with a geometric, the formula is a r to the exponent n plus 1. So that is why I'm saying you will just take the formula, substitute there, being a r to the exponent, that create some space, and say, you're going to say a r to the exponent minus 1, where it is greater than that. So let's substitute. What is our a value? Our a value, is it not 5 over 8? What is our r value? We calculated it to that. And is what they want you to calculate, minus 1, which is greater than 5 over 8,192. This is what I meant by saying, you might not understand that statement, but what you given, you derive some, work it out to try and find the value of n. So some of these things also, it's not like you can learn this in a textbook. It's not like at class or in class you can learn this type of stuff. You only come across this type of things in exam type of questions. So that is why it's very much important that when you practice, forget about the textbook. Just study that once from the start until the end. Make your notes, have your summarized notes, and then from there, focus fully on focus fully on exam type of question papers, and always have the memo. So let's see. What you now need to do is just to work out that problem. You work it out the same way, Bantu Bagit. This thing is a repetition of what we have done. It might look a bit complicated. Tandy, does it look easy or complicated to work it out? Remember?
No, it's not complicated, but I can't say it's easy though.
Yeah, so I expected that. It doesn't look complicated, and at the same time, you may not say it's easy, which means you might not be confident. Okay, so what you need to do is to get rid of that. Always, when you get rid of something in maths, you divide by exactly that, because you don't have a sign of a plus or a minus. That's why you divide. But remember, whatever that you do on the left, you also do on the right. So that means that cancels that, and you remain with 1 over 2 to the exponent n minus 1, which is greater than what is the whole of that? So that is why, Mzozozo, when I started with my lesson on the 2nd of January, I started with all the types of maths problems, the equations, linear inequalities, and so forth. That was because I knew I had to prepare you guys to this type of questions. So it becomes a problem for someone who skipped those lessons, saying they already know those, and they were rushing to say, when are we doing different problems and whatever. Now, when we get to this, it gets complicated. It's because of taking for granted the basics. So never ever underestimate anything, regardless of how a question may look. So let's see. Me, I don't pray. I don't pray. Some things
It's
don't need
1
prayer.
over 1024.
Wait. Let me also punch it. 1 over 1024. Nay, this is what you're getting. Nay. So now,
Yes,
the same principle, you can still apply the same principle and say, since I'm having 1 over 2 to the exponent that greater than, how about I try to check what exponent am I going to get, which will take me back to this. So this is what I'm going to do. I'm going to say half so that I want the basis to be the same. So you're going to have 1 over that. You say to the power of, let's start with 3. 3 is 1 over 8. Okay, it doesn't work with 3. Let's jump to 6. With 6, no, 6 is too small. Let's jump to 8. 8 is getting there, but it's still small. Let's maybe jump to 14. No, 14 is too big. Then I need to go down. 13 is still too big. Let me go toward 10.
It's 10, sir.
Yes. So it works if it's 10. So now you have the bases which are the same. So that means you're having n minus 1 greater than 10. So you take this to the other side, you have your n greater than, what is that? It's going to be 11. So that's how you score yourself 4 marks for this question. Without you understanding what the question wants, you can still be able to work out that and gain some marks somewhere. Let's see. I'm not sure if I lost you guys there. Can someone just confirm if you are lost or we are still together there?
Still together.
We're still together, sir.
So what I was trying to say is, this is how I would work it out without me having to understand exactly what the question says. I'm pretty much sure that I'm still going to get some marks. Whether that final answer is wrong or correct, I'm still going to get some marks. So I think we will have to revisit this question when we get to that stage where we are able to interpret that question and fully understand what it means. But in short, they want you to determine the last value of n for which Tn is greater than the whole of that. So you might find that with what you have done, you still need to work out something there for you to directly answer that question. But I've just worked it out, assuming that I don't understand what that question says or instructs. So 2 to 3 marks you can score those marks if this final answer still needs to be worked out. So I think last thing that I want us to quickly do is to just go through that previous question. We no longer need to see there, but can we quickly check 2.1.1? It says write down the values of the next 2 terms of the sequence. That you can easily do because it's a quadratic. You know what to do to get to there. The next question says determine the general term of the sequence in the form of. That one also, it's easy because you know those 3 formulas. But I want you guys to have a look at that third question, which says which term in brackets there is S. If a question comes and they're saying which term or terms of the sequence will have whatever 74. So for those who don't attend all of my lessons, Hamisa, they are going to miss this important information. If you remember, I did say when you're having a quadratic equation or quadratic number, you're going to have 2 possible values. I'm not sure if you guys still remember, but I said you're going to have two possible values, where the other one could be maybe -4 and then the other one could be 7. Then we know that this is the one that we cross because of it having that negative. But in this case, you can possibly have n being 7 and again, or n being 4, both of them being positive answers. How are you going to choose which one is which? Because both of them, they suit to be an answer. This is where that comes in. So when something is written in this way, it means you can either have one term or more terms. That is why when I send a notification in the group, sometimes I say a time for 2 days, then I do a lesson, and then inside the bracket I say S. That means we can possibly have one lesson or more than one lesson because of that S. So in this case, it means you can either have one possible answer or more than one possible answer. So when you get to this situation, you don't cross any, you just leave it as it is. So that means you have two possible answers to that question. Does it make sense, guys?
Yes, sir.
Yes, sir.
100%. So that's what I wanted you guys to be aware of. I'm telling you guys, such info, you might not easily get it in your class, but you only come across such questions in exam. So that is why I'm training you for exam type of questions. So I think, sure, we've gone for 2 hours. So even though we say our lessons run for an hour and it goes for like 2 hours, just always remember that you no longer have time, you matriculants, you no longer have time. So that means every little time that you have, you need to invest it in education, because this is where you to say for all the grade 12 learners, they have less than a, let it be mathematical, and say they have less than years worth of time to prepare for the rest of their life metric. So if for some reason it gives you extra 80 years after grade 12, imagine if you play while you're in grade 12, you don't take your education seriously, play, you are going to struggle for the rest of your life. You just lived, if you are in grade 12 and you are either 17, 18, 19, whatever, that means you still have 80 or more than 80 years to live. And you only have less than a year to prepare for those many years. So in short, Bandipakit, you no longer have time. Whatever time that you have, you need to make sure that you focus on your studies. Even when you laugh, I used to say there's no time for you to be laughing for a longer time. Kwa, 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 kwa. You don't have time for that. You just say, ka, and then you're done. Maybe when you're about to sleep or when you're sleeping, you'll just continue or finish off that laughter. But during the day, kwa, 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 kwa. Mzozozo, do you allow me to sign out, a honorable member? I see these guys are no longer in the lesson and they're busy laughing there. Mzozozo, I'm not sure if Mzozozo is there. Mulebogeng, can I leave?
Yes, you can.
Guys, I do thank you very much for joining. My name is Desmond, Mr. Alex. You guys have a very good night, and I'm out.